Hello A-level students, this is question number 8 of the March 2018 paper, and it is a partial fraction question, so we're going to get started. Notice it's for 5 marks for the part 1 and then also 5 marks for part 2. So the first thing we're going to do is we will need to try and break the function up into 2 parts. One will look like this, a over 2x plus 1, where we need to solve for a. And then we need to put something over the x squared plus 9. Now, because this is a quadratic factor, it means that we must have a linear factor on the top if it's going to be a partial fraction. Because we could have an x term as well as a constant term. Alright, and of course that must equal the other function on the other side. So if we found the common denominator and multiplied across, then we'd get the following. We'd get a x squared plus 9a, multiplying this over to that side, and then we'd multiply this to that side, which would give us 2bx plus 2bx plus 2cx, yes, and then also plus, so it's 2bx squared plus 2cx plus 2, just bx and plus c. Now, that being our top part of our function, that must equal the following. It must equal this top part, the 5x squared plus x plus 27. So if I collate these terms, I get a plus 2b x squared and plus b plus 2cx, and then I get 9x plus c. Sorry, 9a plus c. There we go. And we can see from this that the a plus 2b must equal the 5 in the top expression, the b plus 2c must equal 1, and the 9a plus c must equal 27. So I'm going to write those over here. Let's just erase everything else that we don't need. Right. So if a plus 2b equals 5 and b plus 2c equals 1 and the 9a plus c is equal to 9a plus c equals 27. There are my 3 equations. We've got 3 unknowns, so we want to solve for the a, b and c. I'll start with the b plus 2c and write that b equals 1 minus 2c. So let's just rewrite this as 1 minus 2c. And then we'll go and replace that in the first equation, the a plus 2b equals 5. So that will be a plus 2 minus 4c equals 5. Okay, which gives us the same as a minus 4c equals 3. Okay, let's erase a few more things. A minus 4c equals 3. Okay, now I'm going to use the 9a plus c over here equals 27, and we'll multiply the top equation by 9. So we'll get 9a minus 36c is equal to 27. If I subtract this, I end up getting minus 37c equals 0. And that means that c must be equal to 0. Alright, if I put c is equal to 0, then b must be 1 minus 2 times 0, which is just 1. So then b is equal to 1, and then putting that in the first equation, the a plus 2b, I get that a plus 2 equals 5, which means that a equals 3. Alright, so now solve for each of those variables. Let's go and write them in the original equation that we had. So Let me just erase here. So my partial fraction was basically 3 over the 2x plus 1 plus x over the x squared plus 9. Okay, so there's my partial fraction solved, and that's for 5 marks. Now the second part asks us to do an integration on this, okay, from 0 to 4. So we're going to do 0 to 4, and of course remember, if we can do that, then we can break it up into 2 integrations. So the first integration is simply, we ask if we've got 1 over a linear factor in x, then that means we have 3 ln 2x plus 1. Okay, so the first part will be 3 ln 2x plus 1, but of course we can also derive the 2 so therefore we end up getting because if we derived the 2x plus 1, we'd have got 2 over the 2x plus 1, and so therefore we must have a half, so it's 3 over 2 ln 2x plus 1, okay, because we would have got the derivative of the 2x would have been 2, so we must cancel out that 2 with the half. Are you happy with that? Okay, so it's 3 over 2 ln 2x plus 1. Now the second integration is a u substitution, because if I said x squared plus 9 is the u, then the du would have been 2x, but we've only got x at the top, so that means we should have started with a half before. Okay, so this is a half ln u. Okay, that's the integration of the second one. So that's plus a half ln u. Now, we want to integrate the first one from 0 to 4, but the question is, what do we integrate the second one from? You might just suddenly think, oh, 0 to 4 as well. But remember, we've changed the variable. And so the u, if we saw here, if we substitute the x in, we substitute 0 in, we get 9. And if we substitute 4 in, we get 25. So we've actually got to do from 4 to 25 for this one. Okay, and of course, we know that u is equal to x squared plus 9, so we could go back to the x one if you wanted to, and then just put that back in as 0 to 4 if you wanted. So either way is fine, okay, if we want to do values. It depends on how you want to do that, but just be aware of that u substitution over there, that you change the numbers, the parameters of the integration, if you leave it as u, okay? And sorry, these are already integrated, so we don't want to integrate again. We're just going to use the values 0 to 4. I'm just going to fill it in this side, and of course here the same thing, 9 to 25. Right, so this is what we now want to do. So we're going to fill in 4 in the first answer. Now that means that we get ln 9. So 3 over 2 ln 9 is the same as 3 ln 3. Okay. Now are you happy with what I did there? Because 9, remember, is 9 squared, so I'm going to take the 2 back to the power to the front, and 2 times 3 over 2 is just 3. So I end up with 3 ln 3. Then of course minus, if I put in a 0, which means it'll be 3 over 2 ln 1, but ln 1 is 0, so that's just a 0. Then for the second part, we've got this plus over here, and this is a half ln u from 9, so that's a half ln 25, which is the same as ln 5. Okay, because a half can go to the power and the square root of the 25 to make 5. and then a half ln 9, which is just minus ln 3. Now 3 ln 3 is then minus ln 3 is 2 ln 3, and plus ln 5, which is the same as ln 9 plus ln 5. And remember, plus ln means it comes from multiplication, so that's ln 45, and they wanted the answer as a ln of a single number. So there is my final answer of ln 45. Alright, so there we go. Quite a bit of work in those two, but that is a beautiful 10-mark question. And if you can do all of that, you've got a nice solid 10 marks if you stay accurate.